All right, so now that we've got our fracture set up, let's actually rotate some things on here, in particular the helicopter blades. The ones in the front, top, and the ones in the back, and then we'll move the whole helicopter on top of that. So this will remain the area at the origin where we do all of our work. And heli over here will be our animated thing. So I'm just going to say, let's go merge in from our frac geometry container. Let's go get the pieces. There they are. I'm just going to turn this off for a little while. And I'll say get heli. There it is. And let's use a transform, regular old transform SOP here. And we'll have him work. Actually, let's bring that back. Let's have this work on the cat name. So I can just select all the rows at once, the whole assembly at once, just like that. Press enter, and there it is. Now, it's only going to apply this transformation to that. But watch what happens if I spin it. Uh-oh. It's a little off axis. Because right now, the pivot is the origin. It's so close to being the center. But apparently when I modeled it, it did not do it there. If I move the pivot, the whole thing will change. The pivot being essentially where the manipulator is. So now when I rotate, if the manipulator is here and it rotates around that, well, there you go. I mean, it makes sense. It's just not what we want. So let's put this all back. What we can do to find out what the actual center of this whole thing is a little trick where you could say move centroid to origin. So now it moved, it calculated on the fly and found out what the center of it was, and then it moved, and then it applied that move to put it at the origin. Basically, all we need is just not have it move this. But now we have the actual pivot. This is the pivot we want. And now when you see when I rotate it, look at that, it stays right there. So it was so close to being there, but apparently it was off by a little bit. Did something wrong. So there we go. Anyway, so there it is. Top rotors now have this thing, and now we have that. Now we can animate this ourselves, like we could keyframe it. Because this is gonna be pretty constant, we could also just make it in terms of time. So $T, time. I could just say like T times 100. And now this T is in seconds. So as you can see, as it goes, this number is going up and up. And it's rotating the right way, so we got lucky with that. Otherwise, we'd have to do the negative of it. So 100 seems pretty slow. I mean, this is, even playing it, let's say if we did a flip book to see what it would actually look like. So here we go. This is very slow. This is not nearly fast enough for what we want. This is going to be a helicopter that's kind of flying through the air and crashes. So what if we did 10 times that amount? So it's nice to go in powers of 10 to really just jump to what you're trying to get to quicker, and then we can always split it to the difference if we needed to. So we'll see what that looks like. That's pretty fast. Yeah, that's probably fine actually. Because a helicopter, they would spin pretty fast. I could still see it moving around. It's not like it's doing more than one rotation between frames or anything. It looks like it's doing like 40 degrees or so every frame. So, great. That's fine. Now for the back one, that was a little trickier because that one's off kilter here. It's diagonal. So what I'll do here for this one instead is I'll say transform, choose, and remember to be in the 9 mode. I'll say the rear one. There it is. Same thing. This time we're going to rotate around what appears to be the x-axis. Of course, this is going to be way off whack, so that doesn't make any sense. So do this, and then zero this out again. So now we see our manipulators back here at the origin, or at the center of this thing, and now we have it. Now the problem still is that because this is off kilter, this is what's going to happen. Crazy, right? It's kind of rotating back and forth. We don't want that either. So what we can do is, let's get a little bit more precise look at this. I'm going to say, where am I? I want to look through the front. Set view, front viewport. So what we're going to do is, let's transform this so that it's straight up and down. Something like that. We'll just make it even. We'll say 6.5. So we'll say tilt forward. Then we'll actually do the rotation that we want around the axis here. So not this. But now we can actually do the actual rotation here that we want. And I'll just put like half the speed from before, because this is smaller. So say rear rotation, and then we'll want to just rotate it back to the original position. Tilt, restore. And what we want is this parameter, and we'll just refer to it here. We'll say do the opposite of whatever that was. So these two together, you know, this excluded, this is going from here, it's rotating it negative 6.5 degrees that way. This one's pointing it 6.5 degrees. Obviously they cancel each other out. The other thing that's happening here in the middle is this is spinning before it gets put back. So I press space 1 to just come back here again. And now we can see when we spin it, it's essentially spinning around that axis. It's still wobbling slightly just because 6.5 is probably not exactly right, but it's close enough for our purposes. It's, you know, looks like it's fine. So let's see, is it going the right way? Looks like it's going the opposite way. So let's switch this one up. We'll say t times that, just to see. Again, hard to say what this actually should be. This is just artist discretion, but it's mostly gonna be a motion blurred buzz anyway, so it's fine. Great. So now we have a helicopter whose blades are spinning, and that's gonna factor in. That's gonna make velocities and things like that. It's gonna affect in a very big way how the simulation works. So I'll just put a null here, and I'll say animated pieces. Oops. There we go.